morning. On behalf of San Juan College, it is my pleasure to welcome you to our 12th Annual Technology Leadership Conference. Thank you so much for joining us today. First of all, we would like to thank many of the individuals and companies that helped sponsor this conference and organize it. First of all, our Chief Information Officer from CampusWorks, Vinny Ziccolello, who you met earlier today. I'd like for all these people that I recognize and companies to please stand and be recognized. Vinny. And then Galen Harris, who's his executive assistant, and all of our Information Technology Center staff that have helped organize this event. Can you please stand and be recognized? I'd also like to recognize the college leadership team members that we have with us this morning. Will you please stand? We have Edward Despois, our Vice President of Administrative Services. Ron Jernigan, who's our Senior Director for Institutional Research. And now we'd like to thank the sponsors that have helped us with this conference. As you know, yesterday we had a total of 325 people registered for the conference. And this is, we're so thankful that you're here, but we have a lot of sponsors that have helped sponsor this event so that it can be free to our community. So we'd like to recognize those sponsors. So if you take out your brochure, you can see along the bottom we have a multitude. And if you're representing one of these companies, when I call your name, will you please stand and be recognized? So first of all, we have A&M Business Solutions, that's powered by Cellular One. Dickey's Barbecue, McDonald, who sponsored our breakfast this morning, CampusWorks, Fuddruckers, C-High Computer Products, C-High, Wells Fargo, HP Hewlett-Packard, Best Buy, RTI, Riverside Technologies, Technology Integration Group, Troxel, Avionics, Hall Research, PMP Marketing, Ricoa, ImageNet Consulting, and the San Juan College Foundation. I would also like to thank each one of you for being here today. I know it takes a big commitment to be away from work for an entire day. Today you will have many opportunities to learn from local, regional, and national IT professionals. And you'll be learning a lot about the spectrum of technology offerings we have. First of all, you'll learn about NASA space exploration, also about Google Glasses, all the way to how to prevent phishing. We hope that if any of these topics, or if you're really interested in information technology, that you will let us know. We have a School of Business Information Technology and Workforce Development that has an abundance of computer science offerings if you're interested. We also have a complete palette of CompTIA courses in our Center for Workforce Development. And there was an article earlier this week that was published by Mark Lotman, and he is the New Mexico expert in economic development. And they said one of the biggest opportunities that we have here in the state with respect to economic development is to have more location neutral or remote jobs. So these are positions where you can work from home and work for companies, especially in information technology. There's a huge growth nationally, so it's a great opportunity for us. One example that I'd like to share with you is one of our strategic partners here at San Juan College is IBM. They have hired interns that work here in our community for IBM. So if you look at their website, just for IBM, they have over 1,000 location-neutral jobs on their website. So if this is of interest to you, I encourage you to talk to any of our San Juan College members. And if you're a member of the San Juan College team, can you please stand and be recognized so our audience members can also talk with you if they're interested in any program. So San Juan College employees, please stand. That's your cue. So this is our extraordinary staff here at San Juan College. And if there's anything we can do for any of you throughout the day, or if any of you or your relatives or friends are interested in attending San Juan College, please don't hesitate to let us know. That's our job, that's why we're here, and thank you and have a great day.
I'd like to introduce Lynn Lane, one of our technologists in the ITC department.
Good morning. I'm introducing Andrew Thompson. Andrew is a design engineer at Lockheed Martin in Denver, Colorado. His current project is working on the heat shield for NASA Orion space program. Prior to working at Lockheed Martin, he worked for Cummins, where some of his projects included the 2013 6.7 liter Dodge Ram Cummins, the Cummins 8.9 liter engine, and even the Cummins 2-stage 50 liter. Quite an experience. All right, Andrew grew up in the Aztec area, helping his grandparents farm south of Durango. He and his twin brother are the youngest of 4. Andrew loves to mountain bike and rock climb. He played soccer for Aztec High School and graduated in 2006. Andrew also attended classes here at San Juan College, and he received his bachelor's degree in mechanical engineering from New Mexico State University. His master's degree from mechanical engineering from Colorado State University. I have known Andrew longer than he remembers knowing me. I am so happy to welcome to the podium as our 2016 Technology Leadership Speaker, Andrew Thompson.
First, I just want to say it's very welcoming to be here, and it's a pleasure for me to be here and talk with you guys today. During my classes here at San Juan College, one of the only C's that I got was here at San Juan College, so life isn't over. So let's go ahead and do a quick history lesson. Back to 1957, that was the year the first anything went to space, and that was a Sputnik satellite by the Russians. Right? That was launched on an R-7, which essentially is a hollowed-out intercontinental ballistic missile. And if they can send a satellite to space, then they sure can send a nuclear weapon to space. And that was a great fear for most Americans that year. So Americans responded that next year, responding with starting NASA, 1958. Let's fast forward 3 years, 1961. 1961 comes along, the very first man goes to space. Yuri Gagarin, the Russian cosmonaut. How did the Americans respond? The very next month, Alan Shepard went to space. First American astronaut. Okay. 6 months later, John F. Kennedy gave his very famous "We choose to go to the moon" speech, 1962, promising us that we will land a man on the moon by the end of the decade. And guess what? We did. 1969 comes around, Neil Armstrong is the first man on the moon. Okay, and we continue to go to the moon, 1969, 1970, 1971, and 1972. Stop at 1972. The shuttle program started in 1980, continued throughout the 80s, launched the Hubble telescope, 1990, continued through the 90s. 1998, the very first module of the International Space Station was put in space. Okay? The shuttle program continued through the 2000s, finally retired at 2011. So here we are, 2016. What's next? What's next for NASA, and what's next for human space exploration? Well, two things are currently going on in the market right now. There is a market for the low Earth orbit, which is under competition between the Boeing CST-100 and the SpaceX Dragon. And they're essentially going to the International Space Station to get American astronauts back on space in American vehicles. The other market is the beyond low Earth orbit, which I find is a little bit more interesting, which is the Orion spacecraft, and that's what I'm here to talk to you guys today. So let's go ahead and get started. But before we get going too far, I want to give a quick introduction to three basic questions about space that you commonly get asked. First and foremost, why go to space? Right? We have enough problems here on Earth, why even go to space? The second thing is, okay, well, you can send robots, you can send rovers, but why risk human life to go to space? Right? And the third biggest question is, doesn't space cost too much? Can we not use that money to fund Medicare, Social Security, military, education, you name it? Right? Okay, so why go to space? Well, I think there's two primary drivers as to why go to space. The first is really answering the big question, are we alone? Right? You can't go to space if you can't answer that question. The second biggest primary cause is colonizing other planets. Eventually, Earth is going to run out of resources. For all we know, there could be an asteroid that hits Earth, but we have to find a way to use resources from other planets. I have here listed are some other secondary reasons, but those reasons are just as important. First is it's inspiring to go to space. I think if you look back to 1969, to when Neil Armstrong put his foot, everybody who had a television was huddled right around that TV. And I think that's going to happen when we go to Mars. Other reasons are that there's technology advancements due to space. A couple here are GPS, digital cameras, not to have that sweet, sweet cell phone if it's not for space. We all have NASA to thank for that. NASA has also provided a lot of benefit with water filtration, memory foam, and a couple others listed there. The last reason I'm going to be talking about is it provides thousands of skilled American jobs. And that's one benefit to the American space program. And then now, currently in 2016, there's been a refocus versus in the 60s and 70s and 80s, it was America versus Russia or America versus China. It's now a collaborative effort, a global effort to land a man on Mars. So that's another benefit. Okay, so why send humans? I think everyone would agree with this, that sending people to space is more inspirational than a robot or a rover. Is that fair?
Yeah.
I think the other reason is when you put people on Mars, or when you put people in space, it's easier to a person to make a quick decision than a robot. A robot has to have a command sent to them. And for you to be able to have a higher chance of finding life in space, well, I think humans give you a better chance than a robot. A couple examples of that is a human, to make a step, he just takes a step. For a robot to be on Mars, he has to wait 8 minutes for the signal to go there, 8 minutes to go back, and he takes a step forward. So naturally, you just don't go as far, you can't explore as far. Okay, and there's an example, I think, for Apollo 17 astronauts went 22 miles in 3 days, and then Mars Opportunity went 22 miles in 8 years. Another big thing is finding life. You have a better chance underneath, deep into the surface than you do near the surface. And Curiosity, the most advanced rover that we've put on Mars, is able to drill 2.5 inches deep, whereas the Apollo program in the 60s and early 70s were able to drill up to 10 feet. And so I think going to Mars, you really do find a better chance in that. Okay, doesn't space cost too much? Well, the pie chart on the left shows the national federal spending, and you'll notice the top 3 categories, which I don't think will really surprise anybody, are Social Security, Medicare, and military. But what might surprise you, certainly surprises me, is a small sliver on that chart is the science sector at 1%. And inside that 1% is a 0.5% which goes to NASA. And that 0.5% covers all of NASA's projects. Not only does it include human space travel, that includes everything that NASA does. Every single thing. And so the bottom line here is that NASA gets half of 1 penny of $1 for the space program. And quite frankly, that's just not enough. And for human space travel alone, gets, I think the number's 22%, so you run the number, that's an eighth of 1 penny goes to human space travel. And so I think the question shouldn't be, doesn't space cost too much? I think space costs too little. Okay, so the journey to Mars, how are we going to get to Mars? Well, I think up until today in this civilization, we have been focused primarily on Earth reliant. That is, we've gone to the International Space Station, we've worked science to understand what happens to the human body in space. We now understand that. We now have been developing technologies to help us get further into space. And in the next 5 years, from now to 2023, Orion is going to be in this proving ground stage, where we're going to go back around the moon, we're going to go back there, and then after 2023, we're going to be focusing and shifting to Earth reliant. That's going deeper into space, further into space, going to asteroids, going to Mars moons, and then eventually landing on Mars by 2028. This isn't science fiction, this is happening today. And really what the focus of my presentation today is primarily Orion and SLS rocket. SLS is a brand new rocket. It's the biggest rocket that's ever been built. It's bigger than the Saturn V by about 20 feet tall. It's about 400 feet tall. It's more powerful than the Saturn V. It's about 15% more powerful than the Saturn V. And then lastly, I want to spend most of the time talking about the Orion crew module. So the most powerful rocket in the world, what is it? So the two white things hanging off the back, those are solid rocket boosters. And those are the biggest solid rocket boosters that have ever been built by humankind. In the middle, the big orange thing is the core stage, which basically holds all the fuel. And if you notice towards the bottom, those are 4 RS-25 engines. And if anybody's familiar with the shuttle program, they'll recognize that. That's the same engine that was used for the shuttle program. And why you use the same engine is it's gone over 30 years of fixes, of problems. You have worked out all the tweaks and major issues that you find with that engine. And now all you have to do is it's the most reliable engine that we have. That's what makes Orion one of the safest things around. Towards the top, you have the stage adapter, and underneath the stage adapter is the upper stage rocket. And the fuel there is a cryogenic fuel, liquid hydrogen, liquid oxygen. Towards the very, very top, which is hard to see, is the Orion itself. So Orion is the crew module and the launch abort system, and the service module goes on the very top, and then at the bottom is the rocket. So talking about this solid rocket booster, you'll notice that they weigh 1.6 million pounds, which is quite a bit. But the most important thing and the most exciting thing here is it has 3.6 million pounds of boost each one of those. Okay, together with both of these boosters, with the 4 RS-25 engines, that's 8.8 million pounds of thrust. Saturn V was 7.5 million pounds of thrust. Okay, so the RS-25 engines in the core stage generate enough power to power, 12 Hoover dams? So, I mean, this is big stuff here. I have a video here of what one of those solid rocket boosters look like. So that was in Utah, 2011. Okay, and that's all I'm going to talk about for the rocket. Now to talk mostly about the Orion multi-purpose crew vehicle, what makes Orion one of the safest vehicles around is the launch abort system that's up at the top. That is, God forbid anything happens during the launch, you have a launch abort system that will protect the astronauts. It is a must-do capability. Oh, we not? Sorry about that. I'll just keep talking. The other thing, the middle section is the crew module. And the crew module itself is where the astronauts live. And Orion is able to support up to 4 astronauts. That's why you'll see when we pull this back up, there are 4 windows for each astronaut. The crew module itself is 40% larger than the Apollo program, so it's quite significantly larger. And then on the bottom, okay, let me just log in real quick. Give this a couple of minutes to load. That's fast. Okay, the last thing, so again, the crew module, just to reiterate here, crew module is where the astronauts live. There are 4 windows for up to 4 astronauts, 40% larger than Apollo. The bottom there is the service module. And the service module is where the solar panels are, provides electrical power, it provides consumables, it provides air to the astronauts, and it does provide some propulsion. And the last is the spacecraft adapter, and you adapt that to whatever rocket that you have. So you have to be able to adapt that. So where is Orion being built? I think this is one of the beauties about Orion, is that it's being spread across 47 states in the United States. Here in Mexico alone, we're using white sands to do some of the launch abort testing. There's also Lockheed Martin and Albuquerque that are doing some stuff too. But in Colorado is where it's primarily being designed. And that's where we're working on the crew module as well as the launch abort system. So what does it take to actually demonstrate and be able to have NASA be happy with the spacecraft? And I'm not going to list all of these. The ones I'm going to talk about are the ones I have videos on. The first is, one of the must-do capabilities is you have to show that the launch abort system will work, right? The second thing is, you have to make sure your avionics systems work. And avionics is it's a mixing of words, which is aviation and electronics. So aviation is your electrical systems. Just a couple to keep in mind are communications and navigation. So that's what we talk about when we're talking about navigation. You also have to demonstrate your thermal protection system's going to work. Okay, when you enter back into Earth's atmosphere, that you're going to protect the crew module. Yeah, and then when you come back, your parachute systems have to work. There's a lot of demonstration about parachutes, about thermal protection, and then lastly, when you land in the ocean, that the astronauts will be safe. And that's the most important thing. So here we do parachute drop tests in Yuma, Arizona. And the parachute system on Orion, there are 11 parachutes. And why so many is when you enter into Earth's atmosphere, you're going so fast that if you were to pull the main parachutes, you would drastically hurt the astronauts. And so what we do instead is, you have the parachutes and you slowly let it out. Big parachutes open, bigger and bigger and bigger until you get to the main parachutes, which are, each one of those are about the size of a football field. So they're quite large. And then when you land in the ocean, we land about 20 miles per hour is about the max that you have. And here's a water drop test with a dummy in there, and then we take measurements off the dummy to make sure that he's going to survive just fine. Another capability that we do is we obviously have to be very well integrated with astronauts. We have to provide crew simulation modules for when they're in there, they can practice what they have to do. They have all the systems that they need to do, and if we need to make tweaks, then we do. Okay, so what is our mission progress to get us to Mars? What NASA has been able to do is we are currently funded up to EM2. And the first test, which happened in May 2010 in Ascent, New Mexico, is we provided and demonstrated the capability of the launch abort system, which I'm going to show you in a little bit. And then our next biggest opportunity was in December 2014 with EFT-1, or Exploration Flight Test 1. And what that test was, is we went 3,600 miles beyond Earth, which is further than we've gone since Apollo, okay? And we demonstrated all of our capabilities. That is launch abort system, that is all of our avionics works very well and passes through the Van Allen radiation belts. And we came back, we demonstrated that our thermal protection system works flawlessly, that our parachute system works flawlessly, and that we landed in the ocean and we provided that we can pick this up and everything's okay. And our test in December 2014 demonstrated how well Orion is. Our next biggest launch, which is coming up in 2018, is EM1, or Exploration Mission 1, which is unmanned, but what we're doing is we're going around the moon, going beyond 50,000 miles beyond the moon, which is further than any human spacecraft has gone before, and we're doing that in 2018. The next biggest one is another launch abort system test with the entire stack. And then lastly, our very first crewed mission, which will be EM2, and that will be back around the moon and coming back. It's a very similar test flight to EM1. All right, so launch abort system. Launch abort system has 3 motors on it. One is you have to control your attitude and your orientation, and that's an attitude motor, which will be one of these that I'll show. Another big one is the jettison motor. So once you get into beyond Earth's atmosphere, you don't need the launch abort system anymore. And so you jettison that off, and it flies off, and everything's okay. And the last thing, which is one of the most critical ones, is the abort motor. And the abort motor is, if anything happens during the launch, you have a motor that can get astronauts off of that rocket just like that. And we're talking 500 miles per hour in 2 seconds. So this first video here is of the abort motor. Second video here is of the jettison motor. And this third video is of the attitude motor. So you'll notice how it kind of keeps it running. And this last video is the very first capability of the entire thing put together by Ascent, New Mexico. Oh.
3, 2, 1, launch, launch, launch.
It's going to do a flip to help slow it down. It's going to roll, does a roll, and then it's going to jettison off with its jettison motors, and then the parachute systems deploy. Notice how it helps slow it down, that those will get cut and then a bigger parachute will come. Then it eventually lands here. And those are the main parachutes. And those are about the size of a football field. And this happened in our own state of New Mexico.
Would that launch abort engine, would that have saved our Challenger crew? We have that?
Well, I think that's a great question. The Space Shuttle program didn't have a launch abort system, if you recall. And that's one of the reasons why Orion is, and that's one of the reasons why Orion is the safest vehicle that's ever been built. Is we have to ensure our astronauts will get back. And as tragic as those events happen, it ensures that we do better next time. And that's what the launch abort system is. Our next launch was in December 2014. That was Exploration Flight Test 1. We launched off Cape Canaveral. We went up 3,600 miles and then came back at 20,000 miles per hour. And the reason why we went to that distance is it's a similar re-entry speed than you do when you get to the moon. The moon is 25,000 miles per hour. And we, again, demonstrated that we'll pass through the Van Allen belts, that our avionics systems are going to work through those. And we re-entered, the thermal protection system is going to work great. Our parachute system is going to work great. This is a great flight test. It's real life here. Our service module, this is what it looks like. That's how big it is. This is the heat shield that I'm partial to. That's what I work on. And the heat shield has two jobs. One is a structural job, the heat shield takes the primary brunt of the load when we land in the ocean. And the other job is to protect the astronauts when we enter into Earth's atmosphere. So what you're looking at is the structural side of the heat shield. The back shells, which cover the side. Interesting fact here is the back shells are the same material that was used during the shuttle program. And the reason, again, to reiterate why we use the shuttle towels and then the heat shield materials after, which is a similar material that was used for Apollo. And the reason is because we have used these materials, we understand these materials, we have made improvements to modify for Orion. And the bottom line is it's safer that way versus having a new material. Here it is completely stacked together with the American flag. Then the red things are what covers the windows. Here it is, we're putting it to the adapter for the rocket. There it is completely stacked. The last thing to do is add on the launch abort system. I think that all of it together is about 90 feet tall. And here's the mission profile.
The vehicle that we see here today, it's not a PowerPoint chart. It's a real space rig.
That is the most important thing for all of you here.
This flight test was the first step in realizing our ultimate goal, which is to go to Mars.
4, 3, 2, 1, and liftoff. At dawn, the dawn of Orion, and a new era of American space exploration.
This is a lot of the best navigation system that's ever been designed or implemented. It's unbelievably
That's real footage there.
robust and intelligent. It can do all sorts of smart fault detection. It's a very smart system.
We all eagerly anticipated the climb of Orion from low Earth orbit to its apogee over 3,600 miles from Earth. And there it was. We had a view out the window, and we could see the curved sphere, just like back in the Apollo days. Amazing sight.
And that's a real
This flight test went through the Van Allen belts not just once, but twice. And this flight test proved that the avionics inside of Orion were able to handle that high radiation environment. The heat shield on Orion is the largest heat shield ever made. Orion came home, hit the Earth's atmosphere at a blazing 20,000 miles an hour.
Really helped, I think, put the exploration mission to see that capsule come in as fast as we expected. And see the parachutes go. There's really not been a film of that kind of deployment, or how dynamic that is. So I think it's huge.
Splashdown. Bullseye splashdown for our new spacecraft.
For an engineer, it may be as cool as an artist appreciating fine art at a museum.
USS Anchorage successfully recovered the NASA Orion space capsule from the Pacific Ocean.
All that coming together is pretty special.
I'm sure you were all as proud as I was to see Orion's first successful flight test.
There is your new spacecraft, America.
Again, so that test flight was really a major proving ground for Orion to verify all of its systems worked. and it really did work as flawless as can be. We're all very proud of it, especially as Americans and people that worked on it too. Here's some posts when it landed in the ocean. Here's some pictures of what it looked like. There's it being recovered into the USS Anchorage. There's it back at Kennedy Space Center. And so that's a pretty good scale of how big that is compared to other people. Okay, so what are we doing next, right? EM1 is going to be launching in 2018. And we're going around the moon. Pick up the video here. Launching again from Cape Canaveral, Florida. We're going to go around Earth to elliptical orbit, go back around the moon. We're not landing on the moon. Going past the moon, about 50,000 miles, and then coming back and landing again in the Pacific Ocean. I have a preview here. Picture of how we're designing this. This is the barrel that came in. It's just the pressure vessel that comes in, and it's the bare back and bones to it all. And then what you do is you add all of the avionics, all the electrical wire, all of that gets added to the outside. And then eventually the heat shield goes on the bottom, the back shields go on the side, and the forward bay cover goes on top, with the parachute sitting in kind of that area right near the top. And that's what it looks like. To give you an idea, so that's 4 windows, so you can see what that looks like too. Here again is the heat shield that we're being built. Where we're at is we've actually built a heat shield and we've sent it to Kennedy Space Center. And the last thing that we have to do is add on the Avcoat, which again is a similar material that was used for Apollo. And then add some instrumentation, and then we can install the heat shield. One of the major things about EM1, which is different than EFT1, is we now have an international collaboration effort, and the European Space Agency is now taking over the service module. And so part of that is a money issue, part of that is an international collaboration, and so now we're getting a global input into Orion. And that's what the service module looks like. Here's what the primary structure of the service module looks like. And last thing is the service module sends out the solar panels, and this was a test, a demonstration that the solar panels will work. This is what all of the avionics and software looks like prior to putting on all the thermal protection systems. So it's a lot of wires. If you bring those all out, that's about 20 miles worth of wires that are on there. This is probably half or 3/4 of all the wires that we actually put on. And the last thing I have here is a video for EM2, which is our first crewed flight mission.
At T-minus 3 hours and more. And we're now in the final 5 hours of the countdown. Crew going down the elevator has been used by the astronauts ever since Apollo.
It is great to be in Florida today. The rocket is ready to go fly. The team is ready to go fly.
the last thing I'm going to say just after this, I have a slide of how you get in hold and how you contact with Orion. Different places that you can look for where our progress is. But really the most important thing I'm going to say right now, is that, like she said, is that, I grew up in Aztec, I went to a community college, I went to a state school. The fact is, there's nothing really special about what I did. And the fact is that I think anybody in here can do that. Okay, it's not anything special that I did. All you have to do is really work hard, and you can work on projects like this. And specifically here in the state of New Mexico, what I've noticed is, being out of state in other schools, New Mexico provides some of the most affordable education in the entire country. Okay? And we're not giving up faculty to do that. We still have amazing faculty here in the state of New Mexico. Okay? And I think that's something that we can all be proud of. But specifically here at San Juan County, through my own experience, some of the best professors that I've ever had was here at San Juan County, and they still find a way to make it affordable and cheap for everybody. And I think that's something that you can be proud of. These are some different sites that you can go on and again to. You can connect with us with any of these sites. Feel free to. There's tons and tons of information. You can learn really as much as you need. Thank you. Any questions out there? No questions?
That crew module doesn't seem like it's a humongous amount of space. So how long would the crew have to be in it if they went to Mars and back? Like how long would that trip take?
So the crew module itself is built right now for 28 days. Okay, so the question was, the crew module looks really small. What are we going to do when we get to Mars? Are they just going to be in that vehicle the entire time? Put that in perspective, each astronaut gets about 7 feet by 7 feet by 7 feet. So it's not really a whole lot of room for all of them to be living in. But the crew module itself right now is planned and it's only capable up to 28 days. And the reason why that's 28 days is it's the time to get to the moon and back. But what we're doing is we're developing habitat modules that you can attach to Orion to give the capability for them to actually go longer. And that's what the next biggest thing is to actually add a habitat to the crew module to make them go deeper into space.
Question. What are the materials that make up the heat shield and how many layers are there?
So the heat shield is specifically, it's a ceramic material. And it's the same material for the Apollo program. And we actually only have one layer. And what we've done differently than what the Apollo program did is you kind of lay it up all together, and then you cure it all at one time. What we've done to help improve properties, etc., is you basically lay a block up of that. That's a certain thickness, and then you have a couple hundred of those, and then you machine down to the surface that you want. And so it's just one surface. The material it's a ceramic material.
Thank you.
Yep.
Andrew, how do they have enough oxygen for the 28 days?
So the oxygen is actually stored in the service module. So they have big tanks in the service module, and they have pipes that are actually transferred over into the crew module. And I think I can show you a picture where they actually go over. So this white guy right here, that's where a lot of the pipes actually get transferred over into the crew, and that's what provides them the oxygen and everything that they need there. Not only, there's a lot of different things that are passing through there, but that's certainly one of them. Any other questions?
Are the astronauts for the 2028 launch already chosen?
I don't think that they are. So the 2018, the one that we're doing coming up, there's not going to be any astronauts for M1. The very first flight test with astronauts, 2023 or 2022, somewhere in there. I don't think they have been selected.
They're still in high school.
You had mentioned one of the motivations for space exploration is to answer the question, are we alone? Does NASA have a contingency plan if we find someone else?
That's a great question. I think the likelihood of us finding life is more of like an organism or like on a microbiology level. I think that the chances of us finding a more being kind of like ourselves, I think, is a little bit more reduced, or likely to be much further away than, let's say, Mars, which I think there's a possibility of them finding a microorganism that's there or something like that. Possible. Yeah, it's not. It's actually it burns back up into the atmosphere. So once you get up there and then it gets far enough away, then you separate it, and then it's not going fast enough to stay in orbit, and so it actually burns up into the atmosphere.
Is the EM2 and the Orion spacecraft, are they designed to go to Mars, or are they designed to go around the moon?
So right now, our thermal protection system is designed for whatever mission that it is, and you can modify that to however you want. It's currently designed for what its mission is, and there's certain circumstances that makes you have to modify the design to make you go further into space. But currently we're designed to be EM1, EM2, but we have the capability. There's certain things that won't change, like the system to support a human body, or the technology to help prevent radiation. Those things won't change, but there's some things that will have to be tweaked.
Do we have the rocket technology to go further than that yet?
So that's the whole point of the SLS rocket, is to get us there. And it's going to get us further into space than we've ever been before. And that's why it's the biggest rocket, most powerful rocket, and safest rocket that's ever been built.
When we get there, what to say there, if there is microorganisms, what precautions are we going to take to make sure we don't, by any chance, kill those out?
Well, I'm not a biologist. So you might have to ask the biologist, but I think that will be a great discovery. And what you'll find is if we actually do, I think one of the astronauts would be a biologist, and will do the proper procedure, the proper things to make sure that it stays there.
This would be much longer term than we're looking at here, but can you tell us anything about alternative propulsion technologies? I know that electromagnetic propulsion is still being debated as to viability.
Right.
You know, for deeper exploration, we're gonna have to go something more than straight chemical reaction.
Right, and that's probably true, but I think our biggest bet is solar panels, really. And what's nice about solar panels are it's not only NASA that's using solar panels, it's, you know, a lot of different people and a lot of different technologies, you know, are using satellites to use solar panels. So you don't have to only use NASA's money to develop that. You can kind of piggyback on other people that are making those developments. And I think really the answer is going to be a solar panel in the future.
With the international collaboration, will there be more than one country's flag on the final launch?
Right now, since NASA really is the main body, will probably continue to be the main body. Although we are working with the European Space Agency, NASA still sort of oversights that. And because of that, I think we'll always have an American flag. And we might have more flags. I mean, you never know. You might put a flag on their side of it, or, you know, who knows. But I think that's the beauty behind collaboration. You know, because when you get beyond the moon and you look back, you don't see borders, right? You look at what the Apollo program did, you don't turn around and you see, oh, that's America, you know, that's Mexico. It's just the world. Anything else? Last thing I'll say, we're having a breakout. I'm going to be talking more specifics about the heat shield and the thermal protection system. Thank you.